NEC's integration projectors. I just have a few things I need to review. All lines have been muted. This call is a little bit more casual than our CTS courses. So if you have any questions along the way, please feel free to enter them via the chat, and we will get through them as we move along. Otherwise, we can address them at the end. Our presenter today is Matt Griesert, projector specialist, part of our NEC Solutions group. And with that, I'm going to hand it over to Matt.
Thanks, Gina. Appreciate it. Hi, everyone. Thanks for joining today. I know it's right in the middle of the day for a lot of people. So hopefully you're either having lunch or about to, so thank you, appreciate it. One bit of housekeeping I'll throw in at the beginning right now, just as it's up on the screen. I didn't think to make it even easier by writing it up here, but if you see our names here, Mark Knox and Matt Griesert, Mark can't join us today. He has some personal stuff going on. Maybe a lot of you have talked with Mark or know him, so you'll have to put up with me today. But if you do have questions related to integration or any product questions or design questions, our emails are pretty easy. If you have any follow-up questions, so mine would be M and then my last name as on the screen, so mgriesert@necdisplay.com, and then Mark's is M and then his last name Knox @necdisplay.com. So if you do have questions that maybe we don't get to in the chat, or it's more involved and you do want some assistance on a project that you have going on, definitely reach out to us if you have anything. So with that, we'll get started. So this is Mark likes to call this the slide of shame. These are some installations that our solutions team has kind of collected over the years. These are actually fairly recent. The sheer amount of keystoning on some of these makes me cringe. The bottom right one here even has a ceiling fan somehow in the mix there. I don't know how that works. So what the intent is to make sure that if anyone has ever seen an install like this in the past or not, we're definitely going to keep it out of anyone's future. And I'm thankful there's no NEC logos on any of that product in any of those pictures. So we'll move on to kind of what the agenda is for today. These are some big how, what, when, where, why type of questions. And the reason we have the slide and we kind of put these bullets up here is that, as a lot of people know, projection is much more of a system than other types of display technology. If you were to spec in a direct view LED wall, if the budget allowed for such a thing, you really have so much headroom with brightness and ambient light handling, et cetera, where a lot of concerns maybe kind of are put into the background. Projection, you definitely have to look at as a system. So it's often been said that projection's a two-part system. You have your projector, you have your screen or your projection surface. There's also a third factor, and that is the environment it's going into. That has to do with room light, environmental reflections, even all the way to the HVAC, and if that's going to be impacting the screen. Is that going to move? Are there vibrations above you on a floor above, or other considerations to be taken into? So jumping into that, who is going to be the primary viewer of the display? Are they close? Are they far? Are they on the very sides? Who's going to be the primary, and how many people do you need to be able to get impact from the content? As you move to the content, what is that? What is the content going to be? Is it informational? Is it interactive, or is there going to be a lot of consideration of the content, interacting, maybe like an education type environment? Is it going to be video? Is it going to be still? Is it going to be something like we're looking at here, a lot of white and minimal amounts of color? Is it going to be a spreadsheet? So those things are all important when you factor in screen type, projector type, etc. What time of day is viewing going to be taking place? We, as a manufacturer, we typically assume a number of things when we make a product. If we make something that's great for corporate or higher education, we typically expect that it's going to be during normal times of business, right? Kind of an 8 to 5, 8 to 6 type of time frame. But that can change, especially if it's going to be something that's experiential, or it's really just going to be at night, maybe even outdoors, right? So where is the display going to be used? This is pretty typical. Again, like we just said, we would assume maybe a classroom or a boardroom space, a huddle space, but it could be outside. It could be video going onto outside the buildings, onto the ground, trees even we've done. So this is really important. What is the intent with the content and with the system? So how are they planning to connect to the display? Is it going to be HDMI, HD-based key, any number of digital inputs? Do they have legacy infrastructure in place where they want to put maybe VGA or something analog into the display? Or is it even going to be wireless, right? And if it's going to be wireless, how many wireless connections do you need? Is one fine? Is there a number? How is that going to work? And then also a lot of the, as a company, we've been talking a lot of why recently. And so I'll just say this is a really important one. Why are you putting this here? You know, what is the overall end goal of what the display or the content, what do you want to portray? What do you want to get across to the viewer, right? So if a projector is currently being used, are you going to replace it with just a brighter projector maybe? Keep the same screen? You know, why? Why are you going to do that? What was there, and are you replacing it? And then moving to the very end, are there additional factors that maybe need to be considered with the room, right? So maybe the screen is where it lives currently, and you're just trying to look at a projector to fit into that current area to hit and just update what you have. But maybe that screen would be value in moving that to an opposite wall or an adjacent wall and really maximize the use of that room, right? Maybe the professor or someone will tell you that past 3:30 in the afternoon, it's really tricky to use that room. So there's a lot of things to look at, questions to ask, as opposed to just constantly retrofitting. Sometimes we can upgrade hardware and not really see the benefit of the additional cost involved and why we did that upgrade, right? So now moving to one of the big sources of conversation, and really honestly more lifeblood that's been breathed into projector in recent years is laser light. This would also cover pretty much any solid state light source, so LED, laser. They have a similar behaviors in how they operate, so they would also kind of fall under that umbrella. But for here, we'll just talk specifically to laser and solid state. So in green here, you'll see these are some of the advantages that they have, and some of these are quite serious, right? Decreased total cost of ownership. This is really important, and it's reflected in our portfolio of projectors currently and future development, in that not a lot of larger projectors, let's say 6,000 lumens and up, are you going to be seeing purchased with lamps? And that is largely due to they need multiple lamps. So if you need an 8,000 lumen projector and that takes dual lamps to do, you're almost doubling your lamp cost there, right? So laser with no lamp cost, there's a definite added benefit to the customer and to maintenance costs there. 20,000 lumen continuous maintenance. As a tier 1 manufacturer, that's really a minimum at NEC that we use to spec laser. Now lasers you can drive at kind of an optimal level. You can overdrive them, you can underdrive them. There's a pretty much agreed upon half-life for laser and projection among tier 1 manufacturers like NEC, and that is 20,000 hours. And so that is a half-life. So we expect that half the light output will be coming from the light engine at 20,000 hours. Fail-safe, so laser diode configuration. And I think we have a slide, or we can talk about this in more depth later, but if you think of those projectors that are depicted on the right there, those will have well over 100 laser diodes in them. So if each one of those operates like a little lamp, if 1/100th of your light goes out if a diode goes offline, and you have 99 more, you're not going to see that. The amount of diminishing of the light source on that is going to be so minimal that you won't notice it. If it's a single lamp projector, you're very much going to notice it because it's going to go black, right? It's going to turn off. Moving also forward, light source intensity adjustment. there's a slide that talks about this later. This really has to do with blends or systems where you're using multiple projectors adjacent to each other, and you want to be able to match them closely and then have that track over months and years of use. If you have a 4-unit wall, let's say, installation, whether this is like a museum space or even a control center, you don't want to have to put a new unit in and then it's much too bright and you don't have granular enough control to dial it down to match the others, because that is an issue with lamps. You don't have very granular control. It's kind of eco 1, eco 2, or full, right? Color critical, we touched on that just a second ago. That plays interdependently with the light source intensity adjustment. Color critical, laser projectors maintain their color longer. As they degrade, it's very predictable, and you don't have lamp changes. So you don't put a new lamp in and suddenly it drives red a little harder than the previous lamp, and now you have a lot of adjustment to do, right? Time saving. So I say this to a lot of customers in different verticals, but it operates like a computer monitor. You can turn it off and it immediately goes off. You can turn it on within about 2 seconds it comes on, right? So it acts much more like an appliance. And so the behaviors and the ways you can approach the projector, there's not cool down times to think of. There's no control situations to think about with, okay, well, we have something that needs to cool down, or we have all this, boot up time before we get to a screen, and we need to kind of factor that in. You don't have any of that, right? Tilt-free and portrait. Some of the later generation of lamp products, even I know our current lamp products, will do some tilt-free and portrait orientation. Laser can do any kind of strange orientation. The way the laser diodes behave and how we can get air around them to cool off, a lot of them even are liquid cooled. There's not much limitation on orientation with laser projectors. And that has to do with how gravity interacts with lamps, and they can build up hot spots, et cetera, depending on how they're oriented. And then also NEC display, this was something that was a big deal when we did it. We still think it is a great benefit to the customer, and that is a 5-year, 20,000-hour warranty. So some manufacturers have done longer warranties. This one is 5 or 20, right? So we're essentially saying the half-life of that light engine and really the lifespan of those fans, or 5 years, whichever happens first. And that was moving from like a 2-year warranty previously, so that's a big deal. Now let's move on to different types of the image sensors, right? So we just covered laser and solid state and how important that is to projectors. And these here would be the main 2 types of micro displays used in projection currently. There are some other kind of one-off. You'll notice LCOS isn't on here. That's a much more smaller percentage of the market, but the big ones are DLP and LCD. And there's really benefits to both. So typically LCD, because it offers a discrete red, green, and blue panel to drive each color, the LCD kind of value proposition, if you will, is great for a number of mainstream applications. You get good color, and it's an overall great value for the application. Now, there are some inherent disadvantages of it compared to DLP, and a lot of that is native contrast capability. Because DLP does not filter light through it, it does have a contrast advantage inherently to the technology, and it's also surface mounted. So like if you go into a cinema currently with very, very large projectors that put out a lot of light and therefore heat, and also run, not currently, but usually run all day long, DLP is a better technology for that because it's surface mounted and we can get that heat away from the image device, right? So there's some pluses and minuses of both, and we'll kind of go through those. So this is something very new, and I mentioned it briefly earlier when I was talking about laser, and those same advantages would apply here to this HLD LED, right? And so what is an HLD LED? You're looking at a blown up picture of a module there on the right. Essentially, HLD technology was done by actually a number of lamp companies in recent years. As they see that their lamp business is certainly ramping off, they're looking at other alternative light sources to produce, right? And laser is obviously already in use and being produced. However, laser a lot of times is a little bit overkill for a smaller projector, right? So if you say you want a 7,000 lumen projector, laser is great. That's awesome. It works as far as its volume, its light output, its overall scale. It works great for that. These LED high output LED modules can maybe fall into a 3,000 to 4,000 lumen range, and that's kind of a sweet spot there, right? So you get all the advantages of being solid state, but it's not as bulky or as costly as laser would be, which would be kind of overbuilt. If you wanted a 3,800 lumen or 4,000 lumen projector, laser would be a little bit overkill, right? And so you get the benefits of laser and being solid state, and then you get LED. So this is being rolled into our first ever product with this type of high output LED module. And that would be the new ultra short throw model that we're going to be introducing here. So a lot of you, this would be maybe the first time you've ever seen or heard this model number or these pictures, but this is going to be coming from us. Things are a little bit thrown off with the cadence with the pandemic right now, but this is current. And you can see the input panel here, UM383WL. So this will use the previous LED module we showed on the previous slide. It'll be 3,800 lumens and ultra short throw. So one thing to note on LED LCD projection technology is it's very intense on color. So it has a very wide native color range. And so you have RGB LCD panels as well as RGB LED modules driving those. And so their switching speed is extremely fast and they're highly saturated. So our current ultra short throw lamp product, it typically has more of a green hue. It doesn't drive reds as well. To get the kind of peak brightness out of it, it has more of a green tint to it. This product will hit very high brightness and have a very balanced color. So it's very appealing to look at. It has a much more neutral white balance while still maintaining a high amount of brightness. So this being very new, this being very exciting for us to add into our portfolio. If there's any questions moving forward, any follow-up emails, definitely ask us about these and we can get that information out. So moving into light engines, in my time at NEC, I found that I often am talking a lot about light engines whenever I'm at an event or doing one of these. I'm usually the light engine speaker, so I get kind of a smile on my face because I do discuss these quite often. So this is a 3 LCD laser light engine and what it will look like, right? So in an NEC projector implementation, we would have dual banks of blue lasers, and then one channel is to drive just the blue panel. And we don't, like some of our competitors, combine those into a single channel because we want to be able to calibrate white balance as the unit ages, instead of just being out of the box calibrated, and then 3 years down the line, the white balance doesn't look right. By pulling out the blue channel, we can also then re-tweak the color and the white balance by keeping it separate from red and green, right? So the laser bank number 2 goes through a phosphor wheel here to create yellow. And then that is split out with the dichroics to give us the green and red. And then those drive those separately, right? So that's a 3 LCD phosphor wheel implementation, right? That would be a laser phosphor implementation of 3 LCD light engine. And that would be what is in this product right here.
Hey,
so
Matt,
actually on top, yes.
there was a question on the last slide.
Okay.
UHD laser, is that a WUXGA?
That is WXGA. On this unit here, yeah, I'm sorry. I probably should explain actually the model number real quick. I think that was something Mark's been doing. So the W in that WL, that signifies in NEC nomenclature WXGA. So this would be a 1280 by 800 product. If it was a U, that would be WUXGA, right? That would be 1920 by 1200. I think we can go into that more. Now, there might be questions on, will there be a 1080p or something like that variant, a WXGA variant? We're certainly going to look at that. We just think that for this particular segment of this vertical, where this would go into, is WXGA definitely outsells WXGA from a cost standpoint.
Thank you.
Mm-hmm. Now, as I was talking about on the 3 LCD laser engine, that would be the bottom right projector. That's the laser variant. The top right is the lamped variant of our PA laser. And this is really the middle of our installation lineup, right? These are currently 7,000 and 8,000 lumens per laser. And that's really kind of a sweet spot for a larger kind of, not large venue, but just below large venue, right? So maybe a 16-foot wide screen in a education or in a corporate environment. These products have been on the market for a little while now. They've had some evolutional updates, but big things about this projector were they were one of the first units to have an HD-based repeater built in, where you can chain out to more units, and we'll actually show that in the coming slides. Built-in edge blending, built-in stacking, and geometric correction, right? So with a simple webcam, you could blend 2 or 3 of these side by side, and it's very simple. It doesn't take 7 hours to do. One other thing to note, and we'll cover this at the end of the deck, these projectors are 4K ready, we call out on them, which there's nothing about the image sensors that have 4K pixels. They are WUXGA LCD panels. However, they can accept a 4K signal and just scale that in, right? So it'll scale that in 16 by 9 onto the sensor in 4K UHD, as opposed to saying, putting up a blue screen and saying out of range or input. Now, the most exciting feature of this projector when it was introduced multiple years ago was that it was the first LCD projector that was also filterless. And the thought process there from a design standpoint was that laser projection or solid state projection is really great for the customer or to the person doing maintenance on it, and that they're not climbing a ladder or worse on a scissor lift to replace a lamp. However, we didn't see where putting a necessary filter in it that needed to be changed. Essentially, you still had to be on that ladder. So as a company, NEC said, how can we take the filter out of an LCD projector, right? And so there was quite a bit of work that went into that. This is kind of a high-level image of what happened, but essentially there's a sealed module that those LCDs live in with the light engine, and it is hermetically sealed, right? There is then heat pipes that come out of that, and through a heat exchanger, and you'll see on the very bottom left here, heat receiver and heat sink, that heat moves out of that module externally through those pipes that are sealed within the module. So no external air flows over the light engine. So satellites going onto the lens or onto the panels, that doesn't happen. And also, it's a lot more stable. So the projector is able to cool itself, and it's not pulling in external air over the LCD panels. So it's not as room dependent when you're relying on the projector to actively cool itself so much, right? So it gives you a little bit more design flexibility. Now, this was the first projector to have this design, and we've since come out with another generation that went down to our P series, and that was also the same kind of idea, even improved on further and shrunk down, if you will. And so that's another model that I don't think we're going to touch on in here, but we're moving this technology forward. It's been really great for the industry. Okay, Okay, now back to the HD-based T input. This just kind of touches on, this is the first projector to have this capability, but you can bring HD-based T into projector 1, say here, and simply you could just then take a digital input over to a second projector or a third and put either the same image up, or you can put a different image up, right? So in the next slide, we'll show what the use of that is, but you could come into projector 1 and then chain out to 2, 3, and 4, and then image stack them all, right? You could say, okay, I want to have these two make a really bright image over here, and these two make a really bright image over here, and then stack them. So you could have multiple inputs as the same, or you can have discrete images on each. If you were to do a blend, like a 1x4 or a 2x2, you could have a 4K image, and that HD-based T could carry the image to all the projectors, right? And that's depicted here. So tiling would be what we just described. Pretty neat. You can also take this and do a 1x4 and just chain the image across all 4, right? The only limitation here with this chaining on HD-based T is that it's limited to 4K at 30 Hertz. It won't do 4K 60. So keep that in mind. Another cool function that we've had in our projectors, this goes down to our P-series projectors and then also, of course, the PA and up in our lineup, but we can do command emulation, right? So say that you have some older projectors, maybe 8, 9 years old on a campus, and you want to evaluate an NEC projector in one of the rooms, but you don't want to go and change all the Extron programming that was applying to your maybe Sanyo projectors or your Mitsubishi projectors or something, right? So you can put that projector in that room and turn on this control emulation function of NEC projectors, and it'll just essentially emulate that functionality of the other manufacturer. So the on-off, input select, etc., those things will all translate over, and it'll just do the hex translation internally. Then also we've had customers that maybe have quite a bit of Extron gear that's been implemented, and there was a good cost associated with that implementation, and they don't want to go through and get all the new latest and greatest Crestron gear and then pay to have someone come in and program it all. They just kind of wanted to leave it in place, but they did need to update their projectors, right? So that's a full deployment using the legacy gear, but it functions. Now you'll see we don't call out manufacturers in our on-screen display. That's kind of good manners, if you will, right? We don't expect other manufacturers to do that with us either. But in the manual, it'll tell you which manufacturer corresponds to which command set, and they're numbered 1 through 5. Moving to the roadmap, so we've been kind of focusing on what the PA series looked like, what its firsts were, and features. This is our current roadmap that is going to be happening this year. So on the left here, let's just actually, Gina asked about the question with the WXGA or WUXGA. So if you're not familiar with NEC model numbers, I know everyone's company has a different way they implement these things. NEC's is actually very straightforward from some other manufacturers I've seen or even worked at. But so PA series, that would be the series of projector, right? That would be that class. And then as you move to the right, 8 is going to be the light output. So in this case, just add 2 zeros onto that 80, and it's 8,000 lumens, right? Down at the bottom, 65, add 2 zeros, it's the 6,500 lumen projector. The next number, the 3 that you see on all these, that means it's a generation 3 product. The PA generation 1 and 2 were lamp only, and then generation 3 has lamp and laser, which we're calling out here. The U on all of these on the left is meaning WUXGA. So that would be able to handle 1920 by 1200 or 1920 by 1080 natively. If that was a W, that would be WXGA. If that was an X, that would be XGA 1024 by 768. Also, and less of these available, but we do also have Qs, which that would mean 4K. As you see here, EOL, you'll see in the middle of the screen here, EOL June. So coming up quickly here in the summertime, our Gen 3 8,000 lumen projector will be going end of life. And we will have 2 new models coming in, which will be the Gen 4 PA series projectors. Those will both be laser, available in 8,000 and 10,000 lumen. And I'm sure there's going to be some follow-up questions for that. So definitely, like I gave out email previously, or if you have any questions here that we can answer briefly, it might be more of a follow-up thing, but we can definitely talk about the Gen 4 product. NEC Display Solutions single DLP chip laser. We're going to shift now from our LCD lineup of install projector over to DLP. And this is a light engine that shows a single chip DLP, right? So here we have our bank of blue lasers. Those go through a phosphor wheel and create our colors off of that. Those go through the dichroics and then on over here to the color wheel. And because this is single chip, we would have a color wheel on this and then into the DLP, right? This is a very compact product. This would be very common currently on a lot of tier 1 manufacturers as far as compact single chip DLP and how it would work. This is currently how our PX series works. We actually have 2 banks of lasers on this. It's showing one just from a high level, but there are 2 banks of liquid cooled products on this PX series laser. Now, you'll see kind of in the 3rd or 4th bullet point there, one of the big advantages of this product over the PA we just talked about is it can run 24/7, right? So this can be in more mission critical situations. It has more robust cooling, being closed loop liquid cooled, and it is designed to not have to turn off in a day, right? So, you know, normally a projector might get used in a more casual environment, maybe 7 or 8 hours a day, tops. This projector can run for 24 and not have to be turned off, right? So this is a native WUXGA projector. The PX series is available in 8,000 lumen, 10,000 lumen, and then now we're going to touch on here, coming up here, the 20,000 lumen variant. Now at 10,000 lumens, we have a WUXGA version and a 4K UHD version. They look almost identical. The DLP inside is different, right? All the same advantages that you get with the PA series, you got the bayonet lenses. One of the things that PX adds is an OPS slot. So you could put SDI input cards in there. You can put an i7 computer and have it fully encapsulated in a single unit, one power cord with source device and display device all in one box. So there are some cool advantages with this chassis and some things you can do with it. So now these are installations that all use the projector we just showed. You can even see in that render in the middle, those are PX projectors from NEC using our ultra short throw lensing in a blend. So top left here, that's a very typical higher education type amphitheater class, environment there with the podium, et cetera. PX projector up on the ceiling. Bottom left here, the American Red Cross, that is a command center. Blending multiple units there on that screen in a lighting controlled environment. And then I know Mark is usually on here with me to talk about the apple in the center there. That was several years ago in New York at our showcase. I know Jean is on the call and she was certainly there to see that. I wasn't at New York for that, to do that blend, but it's a really cool application. So a number of projectors were used to warp onto that apple and then blend everything together. It's a really neat application. So the neat thing with projector technology in general is that the surface is whatever you can imagine it being on. As long as you can satisfy, the needs of contrast ratio and having it be understandable to the viewer, the surface, it can be whatever aspect ratio you want it to be, right? And that's one of the really neat things about projection. So moving into the PX series, and we talked about those OPS slots a little bit ago. Those are shown here on the left and the top there. So that one there, that would be an SDI input card for the OPS slot. And now, if those of you who aren't familiar with OPS, that's OPS is an open standard that was originally defined by Intel, so it's open pluggable. There's no, it's not an NEC only thing, right? So any number of anything from a small ARM, Android type, really light PC up to a fully featured i7 PC, you can pop in there. Lensing, this is our 31ZL in the middle here. That is a kind of a very wide 0.7 fisheye lens. It has a powered focus, and then there's a focus ring for the peripheral. You can get some very big images with that in a standard throw. And then we have our more traditional 17ZL, it looks like here in the bottom left. That's a more standard to short throw lens. And then we have, as we talked about earlier, our ultra short throw lens. That's a 0.38 to 1 reflex lens. So you could say, like in a corporate application, you could pull a tile in your ceiling, put the projector with that lens above the tile, and have it come back down over the speaker's head and hit the screen. And no one even will know it's a projector in the room, right? It won't shadow on the speaker. And unless someone walks up and looks up in the ceiling, they won't even really see that a projector is shooting down onto the screen. So there's some pretty neat applications you can do with that type of lens with the appropriate screen, where it essentially looks like a 120-inch flat panel. So it's pretty neat. Again, we have 8 lens options, bayonet style lens options. This is just a few of them. But we have a number of lenses available on that chassis, from very long to short. Now, moving into the roadmap for the PX series, all the same things apply here on the models. This is now PX, which is a step above PA. PA is our kind of mainstream LCD-based laser projection or install projection, excuse me. There's also lamp. PX is currently only laser, right? So these being a kind of a 24/7 mindset, more critical environment, these are DLP and laser. So on the left here, you'll see PX 1005. So that's a 10,000 lumen Q, meaning 4K UHD. So that will actually put 3840 by 2160 pixels on the screen. And then the L at the end means laser. That's nice. Some manufacturers, L does not mean laser, and that's always tricky. It usually means no lens. So PX 1004, very similar to the 1005, but that is the 2K WUXGA DLP in that unit. And then the first generation was the 803. So we moved 803 and 1004 are almost identical in every way, brighter, but we considered that a bump up in generation. So there was Gen 3, Gen 4, Gen 5. Those are all very similar. 1004 and 803 really look like the same exact projector from a generational standpoint, but that was how the model numbers fell out. So we're going to move now to the 20,000 lumen product, and we're going to cover the slides with that. That is coming. That is already available, and it's very exciting. So we'll kind of jump into that. One thing that is kind of jumping off that I should probably touch on here, Panasonic lens support. A number of you might see that and say, what? Definitely reach out to us on that. There are a number of Panasonic lenses that are actually able to be snapped into the projector and will work, right?
Hey, Matt, sorry to interrupt. There's a question here about, is there an OPS on the NP-PX 2000UL?
There is not. There is not on that unit. There's a number of reasons why, but yeah, there is no OPS slot on the 20,000 lumen unit. It has a myriad of inputs, but no OPS slot was designed for that one. And yeah, and there's multiple reasons for that. And if the person that asked that question, if they want to follow up in email or on the phone, we can talk about why.
Okay, sorry, there's one more question that popped up.
Yep.
What is the time period recommendation to cool down after a 24-hour workday for PX series projectors?
Oh, for a cool down? Mm-hmm. There is actually no specified cool down. I mean, there's nothing published, right? So you can run that 24/7 and on multiple days in a row. There are some of these projectors that run continuously with no shutdown. The only thing they do is maybe while it's in use, they make sure the intake is clean so that it's not pulling dust bunnies onto and diminishing air going into the unit. But there is no, okay, you know, 48 hours and then let it cool for an hour. There's nothing specified for that, right? So it can continuously run. So our PA series, we essentially say, let's not exceed 16 hours in a day. The PX is fully 24 hours a day. So now our 20,000 lumen unit is only available in black. Typically when you get stuff with this amount of light output, there's no need to have it be white. It's not going to be on a tiled ceiling 9 feet above anyone's head, right? Key features here, and people will say, why is that not a 3-chip DLP? I will talk somewhat at length on why that is. Benefits here, again, 24/7 usage, considerable lens shift, a number of lens options, and then all the cool things you think of with NEC. So built-in edge blending and stacking, and then a number of inputs, right? So everything all the way to BNC. And actually, let me cover it now, because I don't know if it comes up again later. But the single chip DLP on a very new product is for multiple reasons. One is budget. 3-chip DLP units, we make quite a few of those, notably in cinema, and they look amazing. However, they are large and they are costly for a customer. So this unit, though it has great color, is not designed to be put into a cinema. It's not a DCI projector, but we needed it to fit someone's budget, right? So something that doesn't come up on the bullets here, but there's actually red laser in this as well. So it'll satisfy Rec 709 from a color standpoint, even with a single chip DLP. There are the image is mainly driven with blue laser, but there's a red assist channel as well. So there are some red lasers in there to actually boost the red channel and give it a much wider color. So we attain very nearly a 3-chip color space with a single chip DLP on this unit, which is exciting. That also keeps it smaller and the cost down. And the weight as well, let's be honest. So SSL Types, this is 3-chip DLP. This would be kind of, this is the pinnacle of a 3-chip DLP. This would be kind of a cinema application here, right? So this would correspond to the next unit I'm going to talk about, which is 3-chip, and which does have red and blue laser driving the image. Extremely bright. This would be kind of the peak of our large venue installation projector lineup. You see here on the left, there is phosphor wheel on the left doing the green channel. The reason for that is that green laser adds considerable cost into a product, and we certainly do have it in cinema. It's not as necessary in large venue to have RGB laser. So we do RB laser and then 3-chip DLP. So this actually has its implementation in cinema, in its cinema version, and it fully satisfies DCI color space. And this is what the unit looks like. So these are our PH series. So this is moving up above even PX now, right? So these are cinema grade optics. These are essentially cinema projectors. They have onboard processing, and our 30,000 and 40,000 lumens. We have 2 versions of the same chassis. There's just additional laser output in the larger 40,000 lumen version, right? So these, one, they look amazing. They have extremely wide color, and you can do quite a bit of stuff here. So you could, put this on the side of a building. Very good for like rental type applications or staging, concerts, experiential type applications. Just even over to just, viewing video on a very large surface, right? They have all the functions that I talked of on the PX and PA, and then some, right? So they're just, they are large though, right, and heavy. So this talks about the color space that I just touched on with the DCI. So the PX 20,000, I said satisfied Rec 709, and you can see on the CIE chart here on the right what Rec 709 is and where that falls into DCI. DCI is considerably wider, and that falls linearly within Rec 2020, which is kind of the mark everyone has set for display. That is out on that far edge of really around 75% of human visual perception of color is Rec 2020, right? And that's that dark shaded triangle. So PH3501, that is a 40,000 lumen center lumens projector, and the PH2601, that is a 30,000 lumen center lumen projector. These are native 4K, so unlike the previous models we talked about, which could accept 4K or were, you know, WUXGA projectors, this is a native 4K cinema sensor inside here, right? So this is 4096 wide. They can certainly accept 3840 UHD, but they can also be run natively in 17:9. Now, this is our current roadmap on our PH series. I didn't touch too much on the 1202. That is our 12,000 lumen 3-chip unit that has its cinema variant as well. So we have 30,000, 40,000, and 12,000 lumen 3-chip laser DLP, and those will be carrying forward in 2020. And also keep in mind with these, there's no standard lens. These would definitely always be kind of a la carte, choose your lens for the application. So just keep that in mind. Now, 4K projector portfolio, as I just touched on the far right here, the PH, that's native 4K. And then in the middle, that is our 10,000 lumen PX, that Gen 5 product. That is a 4K UHD 3840 by 2160, a smaller, you know, what DL or TI called the XPR chip, and that's the single chip DLP, where the one on the right is a native 4K 3-chip. And then the PA on the left here, lamp and laser, available from 7,000 up to 8, and then later in the year at 10,000 lumens. Those are 4K input ready, right? So you can feed them 4K and they'll scale it down. So let's talk briefly, and I know the summary that went out for the invite kind of touched on this. So I think some people are definitely on here to hear this and understand this and how this works. Let's just get the whole slide built out. Let's talk about what 4K ready is, and then we'll move on out. So 4K ready, like I just talked about, is our PA series, 2.3 million pixels. And then we'll take the 4K signal and scale that quite well, because at NEC, we have a lot of experience with scaling. We've been in the processing business for many decades. So 4K ready, it will take a 1080p image, 16:9, and it'll scale that, right? So, or excuse me, take the 4K UHD image and scale that onto a 16:9 2K sensor. And that is a physical representation of what that would look like on the screen if it was just left alone, right? Now, 4K enhancement, I want to talk about this. We actually call out Epson here. There are manufacturers out there that have made some essentially made up specs, right? So there is no official spec called a 4K enhancement. There is no official spec called 4K plus or 4K super duper or anything, right? Those don't exist. To be certified as 4K UHD by the CTA, you have to satisfy 8 million pixels on screen, and they have to be addressable. You can't count subpixels, right? So if we were to add in a fourth color, we couldn't then say, hey, that's adding to our pixel count, right? It's not. They have to be addressable pixels. So Epson has what they call 4K enhancement. They can address a little over 4 million pixels. I think it's actually 4.15 addressable, and then they achieve totally 4.6. I have to double check that. But they don't address the 8 million pixels needed to be 4K, and they call it enhancement. So it's kind of an in-between. You can see it's essentially taking a 2.3 million pixel image sensor and just shifting to double it, and then accepting the 4K image and then scaling it onto that, right? So there's multiple things that work, and they achieve 4.6 million pixels. As you move up to 4K UHD, you then are satisfying that 8 million pixel to be certified. So our PX1005 QL single chip DLP product will put 8.3 million pixels on the screen. And that's the outer frame you're looking at, right? The 4K / UHD, right? If we were to take that / UHD away, that would then imply a 17:9 cinema aspect, and that's the 4096 wide, not the 3840. But in 16:9 world, we'll do 4K UHD, and that's our 1005. So we can actually address that many pixels. There's less scaling going on there up, so we don't have to scale up and then have that stair step effect that you would have when you don't have a true 8 million pixel. So that's just kind of to clarify that. Our stance is that we don't make a product that's kind of in between. We either have a 4K product or we have something that can give you an image, but it's 1080p, right? This one is not super important, but if anyone has a kind of throw ratio question, the P, PA, PX, PH, those are our install lines, right? Where we essentially start with laser in our P series and then move here down, but actually up in our line to our PH. And that kind of shows the throw ranges possible. Actually, we should add in here on PA ratio range, we actually have a short throw lens there now as well, which is also like 0.3 to 1. So that about does it for me. If there's any more questions, Gina, if you could, I'm not seeing them on my screen, I apologize.
Yeah. I will leave it open for a few, if anybody wants to type any questions. But thank you, Matt.
Of course.
I'll just kind of leave it open. But if anybody does have any
QA panel.
Okay, you can see it too. Okay, good.
I see it now.
Okay, good. There is one that popped up. What application would need a projector in portrait orientation?
Good question. Much less. Oftentimes, if there's going to be a blend of some sort, where there's maybe 3 or 4 units blended, sometimes we'll put them in portrait in order to satisfy the requirements of the surface they're trying to project on. It's usually more for informational. So if you wanted to put it in portrait and then put information, maybe even like in a hotel kind of meeting space or anything, projector and portrait, put it on a wall with information with a schedule, etc. You obviously don't typically throw projectors outside like you would in a flat panel in portrait, but similarly for informational applications, or a lot of times for experiential, right? And you'll say, yeah, I know you guys always do it at trade shows, and I don't see it anywhere else. And that's valid, but a lot of times too, if you want to take, say, one of our 40,000 lumen projectors or 30,000 lumen projectors, put it in portrait and shoot it on the side of a building, that has been done. I know we had an installation in Phoenix that did that. So at a certain time of night, this content would begin to show on the side of this building, right? And it was being shot from the adjacent building in portrait. So usually it's not, it's certainly not in the classroom where you'd be putting it in portrait, but there are applications for it.
There are questions that are popping up. I don't know if you can see them on the Q&A. I'll let you address those.
Maybe I don't see as many. Okay, now I'm seeing more.
You see them? Okay.
Is there a max number of projectors that can be connected simultaneously to get just one image? Trying to see. This is from Victor. I'm guessing to image stack. We can, with no additional hardware, image stack up to 4. So anywhere from 2 to 4, you could do a stack with the same image. If you're going to have the same image, like maybe in a classroom, and you want a projector shooting on each wall around the room, you could chain that and have the same image. It would be 4. That's an HD-based T, matrix Capability would be 4 would be the limit there before you would need to put any like external Crestron, Extron, etc. Outboard gear in, but it would be limited to 4. Hopefully that answers your question on that, Victor. If I didn't answer your question quite right, definitely email me.
There is another one. Do you have a manufacturer you recommend for protective housing, i.e. cage, etc., for your projectors?
We don't have one in particular that we go to every time. I know there's multiple manufacturers that we have worked with, Display Devices, Draper is another one that come to mind. Yeah, there's multiple ones. And then there's even in the cinema world, there's some ones that we can definitely recommend that are used a lot in cinema without booths. For outdoor type stuff, usually it's Draper or Display Devices. And if you have more questions on that or you want to talk about the specific application, definitely reach out to me and we can cover it.
Okay. Are there any other questions? If we didn't get to them, we can address them aside from here. If anybody thinks of anything, feel free to email Matt, or you can email myself and I can pass it along to Matt as well.
Good deal.
But thank you everybody for joining today. As a reminder, we do have these weekly webinars that you are more than welcome to sign up for. The next CTS course is next Monday, April 27th, which is how to determine the correct display technology that is worth 1.5 RU credits. We appreciate your time again, and we look forward to seeing you on other webinars. Stay safe and be well. Thanks, everybody.
Thanks, everyone. Be safe. Take care.
Thanks, Matt.